Okay, so going to OOP244, we don't, I did not create a report. Did I create a report? We did, right? So it's here. And I'm going to bring up, I'm going to add one more thing to the beginning of this. I'm going to borrow it from last semester. Give me a second, let me bring it up. So this is what I am. That was a me? Okay. I'm going to bring the codes over here too. So this is what I'm talking about. Let me edit it. And thank you very much for all those who did Workshop 0. These are the number of people who did. Thank you. Okay, so I have them all shortcutted, so I'll go through them. All right. Thank you very much. This is what I wanted to talk about Workshop 0. So I'm just going to paste it right over here. And copy that. Okay, I have to pull it for some commit changes. So I just added IPC 144 review. Okay, commit changes. Now that it's committed over here, I have to pull before I push. So this is the repository that I have on my computer here. I'm just going to pull it to bring this change that I just made in. So that's going to bring it in. 3 years later, there we go. Now I'm going to push commit, which is going to commit all the stuff that I have for the review. And I'm going to say IPC 144 review notes. And I'm going to say add them all, which is commit and push at the same time quickly, and done. Okay? So now you are going to have this over here. It wasn't last year. It was like 5 years ago, but I'm just copying from the old one, so that's why you see last year. So part 1, let me see if it's up still. Yes. So this is the review session. If you play it, it's going to go through it. I think it was COVID time or something. I don't know. But anyways, so it literally goes through all the concepts of IPC 144 in like 6 hours. Back to back. At the end of it, I think we all lost around 2 kilos when we were finished. But yeah, so, and the notes for all the things that I have done, the code, let me see if the link is broken or it's good. The link is good. So this is all the things that I have done over there, examples that I have written as we were going through it. So if you click on code, it's going to open up Visual Studio and you have it. It's a good idea to go through it, especially when we are going through pointers and things like that, okay? Yeah. So let's start the session. As usual, I will start it by creating, and creating the Visual Studio thingy, I'll do it for first few times, and then I'm going to make it ready just to open it. But for now, we'll do it. So create a new repository, empty project, C++, next. And then I'm going to select the repository, the directory within the repository. In yours case, it's going to be your OOP244 works. Okay, so in here, I'm going to create it in notes. So it's 02 January something something. So this is going to be 03 January 16th. Okay, oh, I'm not going to create it. I'm going to select the folder first, sorry. Select the folder and then create it like this. Make sure you have checked place, solution, and project in the same repository, same directory. This is extremely important. The reason is that as you see, the name of what we are creating is a solution. A solution essentially means a company is contacting you and telling that I want something to handle my e-commerce, inventory, and accounting, and point of sale. That's a solution. You create a solution, then inside the solution you create 4 projects: e-commerce, point of sale, accounting, and inventory. And that becomes 4 projects. We are writing a for loop that prints 10 numbers. So we don't need to have a solution and 4 projects in it. That's why we place the solution and project in the same directory, which means we just one project to work with. So for now, do that, okay? Later on, when we come to inheritance, you're going to see that I create a solution with several projects in it to keep track of how things are happening. But by the way, you have the microphone, my friend. What was inheritance? Remember that?
When we use an object and use it as a parent of another object and add some features to the first object.
Fantastic. So let's replace the object with class. Okay? We have a class. And we have that class, and we use that class to create a new class to add features or remove features from it. Beautiful here. Do you know what's the difference between an object and a class? I haven't taught it yet.
Class is like a bigger thing. It's like a factory, and object is made from that factory.
Your example was correct. Your explanation was wrong. Do you know what's the difference between a class and an object? I did not teach it yet.
I just guess. Class is like a model, and the object is we create something from that model.
Beautifully said. So integer, A, B, C. Integer is the class. A, B, C are 3 objects out of the class int. Got it? That's why I said replace, because you can never inherit from an object. An object, I cannot inherit from me. I have to inherit from human, male, that is me. Okay? To create something else. I don't know if we have any inheritors down there yet. It was a long time. Anyways, forget about it. So what I'm saying is that class is the model, and you can pass the microphone to the gentleman because it's going to be next, and then the lady, and then we're going to go like that. And then you keep going like this. And sometimes I get the microphone, I give it to the next person. 3 passes. If you don't want to answer, you're not in a mood, you don't know what the answer, you simply say pass. Microphone goes to the next person. And when you hear the pass 3 times, it means you can come to rescue. Which means if you know the answer, you say, I can say that. Then microphone comes to you, and it continues from there. Okay? We good? We know the rules of the game? All right? Hello, welcome. There's somebody that's later than me. I'm happy. Okay, so, and very serious too. Smile. It's a good day. What threw me off is how compiler works. And believe it or not, I talk about the same thing in OOP244NAA, but still people don't know. Okay? So that's the reason for confusion. Hello thingy, we talked about it. We said the very first polymorphic thing that you see over here is the insertion operator into cout. It's polymorphic because it has many shapes. You use the exact same thing to insert different things into the cout that is console output. And we have the same thing called console input, which receives everything based on what we have. I'll explain today. And polymorphism is, do you remember what polymorphism is?
Pass.
There you go. See, that's how you do it. Pass? Okay. Gentleman over there. Polymorphism, remember what it was?
It's one thing can do one thing can do different things
in the same way.
in the same way. Yeah.
Fantastic. Yeah, to give it to the next person. So, no, that's the next person.
Oh, yeah.
Okay. Okay. So doing the same thing in different ways. So as you see, it's printing. The job is to print, but it prints different things in different ways. Okay? So that's why it's a polymorphic thing. Then we talked about namespaces, how namespaces prevent conflicts. We can create namespaces. Within namespaces, we can create classes with the same name, and they are clarified by the namespace that they are in. We talked about education and finance, and we put the things in there, if you recall. Anybody problem with that? No? All right. I showed how the conflict happens. If you have conflict, you actually have to qualify it. So you can start using namespaces. We said when you are dealing with a namespace over and over and over and over and over in a CPP file, a source file, you can simply say using namespace yada yada, whatever the namespace is. Therefore, you don't have to use the namespace and scope resolution over and over. But if you use two namespaces that they have the same object in them, same class in them, if they have the same class in them, you need to make sure you qualify them. If you do not qualify it, we said that the compiler is going to say, hey, I don't understand which student you're talking about. You use namespaces of education and finance. They both have students in them. So clarify that for me. And we talked about header files, and we said an empty header file for us is a header file with safeguards and the namespace you are all programming in this subject and OOP345 will be Seneca. So all your code will be in Seneca, and main usually uses Seneca. Okay? One thing I did not mention to you, and I'm going to mention for you, it's a capital crime if you use a namespace in a header file. I cannot say using namespace something in a header file. Why? Because the sky is high at the moment. Just accept that as rule of Farda that told you never write using namespace in a header file. So if for some reason you need to use the std namespace, that is, you need to study before you come to class. Go ahead. std. std.
Pass.
Anybody std? Okay. Okay? Are we good? STD is not what you're thinking of standard. It works for standard. Okay? Okay? So it's standard. With STD, I'm not going to say what. I mean standard. Okay? When they added namespace feature to C++, they said, where do we put all the classes that we have in the library of C++? They say, we're going to create a namespace called standard, call it STD, and put everything in it. Therefore, STD is where IOStream is in, standard library is in, all the little things, FStream is in. Anything that comes in C++ as its parts and pieces, they are in STD namespace. Yes, my friend.
So the IOStream, do we still have to define the IOStream even though we're using the namespace?
Okay. Amazing question. So the question is that if I actually am using namespace STD, do I need to include anything? Now, when I explain what the difference between the two is, you will see. Okay? We need to understand what that hashtag is. The hashtag that you see at the beginning of that, you are talking different language. So when you are writing C or C++, you are using two languages, not C++ or C. You are using, so let's say we are writing C++ and we are using hashtag. When you are writing hashtag, you are telling to compiler to do something before compiling your C++ code. So anything that comes after hashtag is not C++, is compiler language. It's C++ compiler language, telling to compiler to do such and such before program begins. And I give this example to everyone. So in here, I'm going to create a file. It doesn't have to be in header files. I'm just adding a file. Let me just add it right over here. Because header files go under header files in here. By the way, the folders you see in Visual Studio, they do not exist in the file, on the hard drive. All these things are kept in two files that you need to always carry with you when you are passing your projects around. And that's when you push and pull, that's what actually goes into the repository. That's not being ignored. So just to show you what I mean by that, I'm going to bring the notes directory up and go to the last day. You see you see these two files, VCX proj and VCX filters. You see these two? These two are the ones that all the information of these filters, they are filters, not directories. These filters are shown in. So all your header files and files reside within the directory. Which one appears over here is hidden inside these two files. And that's what you carry around. That's number one. Okay, so remember that. So you don't see this directory structure in your project file. That's number one. Number two. So when I create over here a header file, I'm not going to add a header file. Add a new item. I'm just going to write over here. I'm going to write over here. Dot okay, is that good name? All right. So I add this file over here, dot and over there I'm going to say include IO stream, and I'm going to say using namespace std, and in here I'm going to say int main, open curly bracket, and stop. Save it. Got it? Okay? And the other one, I'm going to create over here, add a new item. And this one, I'm going to call it foo.fa. Okay? So another garbage name. Okay? And I'm going to add that one. And in here, I'm going to say, see out what the heck. Return 0. And I'm going to close the curly bracket. Right? When you look at this one, and where's the other one that I created? Oh, there you go. If you put these two together, you have a complete program, right? It says yada yada int main. Then in here it comes print and return 0, right? Now in my main in here, so I'm going to add main, add new item. Program.cpp. In here, I'm going to say include dot that was the thing I called. Is that correct? You remember? Is it? Yeah. And the other one, I'm going to say include foo.fa. Right? And I'm going to compile and run it. Ta-da! So include is only copy and paste. When you say include, you are telling to the compiler, go get the content of that file, paste it in here before you compile my code. Therefore, namespaces has nothing to do with includes. When you are including, you are bringing all the prototypes and all the good stuff that you need to have. Okay? And namespace is a C++ code. It has nothing to do with the hashtag. Does that answer the question? All right. So keep that in mind. Any hashtag thingy, like, for example, just a second, in here, when I'm doing this, what am I doing? I'm saying if Seneca student underline H is not defined, continue compilation. So the code will get compiled. Then in the second line, I'm saying define Seneca student, yada, yada. So it's too late. If is passed. It's going to continue compilation, but within that process, that Seneca thing is defined, right? So if the second time this file is included, because the first condition checks it and sees that defined statement has happened, it's not going to get compiled. Therefore, you include this 50 times, it's going to be included only once. That's why we call it safeguards. Clear for everyone? Again, anything with hashtag, you are talking to compiler before compilation happens. So pass one. A compiler does, I showed you when a compiler works, when you write 4 files over there, it actually runs 4 times. Remember that? And then the linker calls and all the promises, yada, yada, I mentioned. That's the compilation process. But each file that is getting compiled by itself, it has several passes. Hopefully, you're going to go one day to university and you get compiler design course and you actually see what I'm talking about. So there are different passes. The first pass that the compiler does is going through these hashtags and eliminating them. So the compiler keeps going through the code and executes all the hashtags until there is no hashtag left. All the code is pure C++. Then it starts translating. Are we good with this? Therefore, when you write a define statement, a define statement is just a search and replace. It's as if you wrote an email and you referred as he to someone, and then you found out it's a she. Oops, my mistake. You simply say search for all he's and change them to she before you send it, right? Define is that. When you define, you are saying search for all these phrases, replace it with the other one before you actually compile my code. That's why when your define statements are done, the errors of the compiler becomes a little fuzzy because you say, for example, change max with a less than 5. And then you get an error on a less than 5 under max. You say, what the heck, this is max. It's not a, because you did a define, it changed everything, and when it compiled, it gave you an error of what has changed after hashtags happen. Be careful, okay? We're going to come to all these things soon, all right? Questions? Suggestions? Objections? All right. And if you think I'm going too fast, slow me down. Remember, it's the beginning of the semester. We are in no rush, okay? And that's why your workshop 1 is due next week. Relax, okay? Just learn and do your workshop. My coffee is cold, yeah. But it's okay. Anyways, so let's close all tabs. And this one I'm going to say a include.cpp. Okay. Are we good? Do you know why they say bless you? Yeah, say when you sneeze, you die for a second. That's why they say bless you. You die for when your soul goes out in heaven. Okay, anyways. So, that's that. And now I'm going to, again, as I mentioned, I'm going to open the outline and go through the thing. So object terminology, we talked about it. Modular programming, we know what it is. We're going to remember what I told you about how we study. Okay, I'm going to mention it one more time, and hopefully we're going to remember it. Okay, so how we study. So this is what we do. This is what we do when I say we study. Number one, for every session that I have, you need to do 20 minutes to half an hour, depending on how smart you are. Okay, 20 to half an hour of review of what I have taught in class for every session that you have. Okay. Then this is just to not to practice, just to remember what I said. Okay, 20 to 30 minutes going through what I have said. The notes, you look at the notes, and if you remember what I said, fine. If you don't, you listen to the recording, you try to do the thing yourself. And then a week later, 10 minutes, a month later, 5 minutes. And then that lecture is into your brain, okay? That's number one. That's curve of forgetting. That's a known fact. Number two, to practice, you get all the things that I have in here, okay? The code that I write, you look at it, you look at the code that I have, you try to understand what it does, then you set it completely aside. You create a folder in your OOP244 works repository, call it practice or whatever. And you put week 1, and you try to replicate what I have done without looking at my code. So you're essentially copying my code using your memory only. You try to do it. If it happened, if it was successful, fine. You go to the next one. If it's not successful, you set your code aside, close it. You don't look at it. You look at mine again and try to remember what you have done wrong. Don't look at your code. Try to remember it. Go through it, set it aside, debug yourself again. Debug your code. Do that process over and over until both codes work. When they both work, set it side by side and see how different you have done it with mine. If it's different with mine and it's accomplishing the same thing, give yourself 4 thumbs up. If you did the exact same thing as mine, 2 thumbs up. Okay? Remember that. This is how you practice and how you learn. So don't come to me halfway through the semester and say, what do I do to be able to learn and pass the subject? I'm telling you now. Okay? This is how you study. Please, I beg you, start now. Okay? Again, you saw the curve that I drew. Okay? It's now time to catch up. When I go past, exponentially the information is going to be coming quicker. You don't have time. After midterm, if you are behind, you're behind. You need to be an ultra genius to be able to catch up. Catch-upping is now. But if you do that, then the rest of this stuff will be quick and easy. Types. All the types that you have are exactly like C language. All the types you have are exactly like C language. We have character, int, short, long, 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 not just 2. I'm joking. So 2, so long, long. So essentially, this is going to be, okay, who has the microphone? What's a character?
One alphabet.
One alphabet. Pass it to the next person. What's a character? What's a type character? If I'm your 7-year-old brother asking you, what's the character? And you're telling me a character is?
String.
No. Next. Anybody knows what the character is?
It's
You
a
want
character
to
that
say something? No?
the
I
character
hope
is,
you're not listening to music while I'm talking. Okay. Okay. Character is an integer between 0 and 255 if it's unsigned, between 128 to 127 if it's signed. There is no character in C language. We have no such thing. There is no character in C language. C language doesn't understand what is ABC. It doesn't. C language, because of that, they created an integer value big enough to hold the ASCII code of a character, which is 65 for a capital A, 66 for a capital B. So if you want to show an integer, a character, if you want to deal with a character, this is something that we need to know. Like there's no joke about it. Again, has nothing to do with C++. It's just C. Character CH is equal to 66. C out CH. And the result is B. Right? So it has nothing to do. So if I want to actually print the things back to back, I will say CH is equal to 65. Oh, sorry. For CH being set to 65 and CH being less than or equal to Z, I don't need to know what the code of Z is. I know that when you put single quotes, because our brains are not smart enough to remember all the ASCII codes, that's why we have the single quotes. You put single quotes around a character, it extracts its integer value. Single quote Z, single quote is not a character. It's an integer constant that is equal to the ASCII code of Z. We good? So now in here I can say CH plus CH. I can actually say C out CH and CH plus plus and C out and L. Run it and poof. We have BCD. Oh, did I say B over there? CH is 65. I start, oh, shh. Debug my code. Why it started from B? Huh? You don't have the microphone. it's
Because
two
the
equals.
CH was defined 2 times.
No, it wasn't defined 2 times. I just put 2 equals instead of 1 by mistake. I'm supposed to set it to 65 at the beginning to start at A. I put 2 of them, and you see it didn't give me an error. We'll come to that soon. I'm going to explain what operators are, and I'm going to come to that soon. So I should have done this. This is the beauty of writing code online. On the fly. So you see my mistakes, and you see what I do, and so when something similar happens to you, you can fix it. Okay? And I'll go Control F5 now. And now it's from A to Z. Now, nobody asked the question, how did you do that? Is that OK with you? You've done that in C. That's actually C. It has nothing to do with C++. You can write many things over here that you can execute and separate them with comma if you want to. If you want to. So because I wanted this to happen before CH++, I put it before. If I put it after, it would after. Kindergarten way of writing it was this. Right? And you can do the exact same thing at the beginning. So you can separate many executable things with comma. OK? So you can do many things before 4, check the condition every single time, execute the body, and then do whatever you have over here. And you can separate that with many commas. OK? So this is what I'm going to do. OK? So now, in here, I'm going to say, for loop with comma, commit and push. OK? Now I'm going to come back. Did I actually do that? Yes, I did. OK? Now I'm going to actually, let's run it, make sure it works first. No, I made a boo-boo. What did I do? Oh. Yeah. That's a semicolon here. All right. Now I'm going to go over here, commit and push. So now when you go to the repository, you can see the difference between the two and see what it was and what it is. You follow? So now when you are here in the nodes, when you are in the nodes, you're coming here and you're coming here. And you see it says, oh, it changed. So let's see what is for loop without comma. You do this, and you'll see the difference between the two. Got it? That's what GitHub does. OK? So remember that. That's what Git does. My apologies, not GitHub. OK? So you can actually see what it was and what it is now, and you understand. Questions? Suggestions? Objections? OK, so now we know what a CH type is. So CH is simply n. So writing character in a bullet form and then int over here is an absolute mistake. It was supposed to be char, int, short, long, long, long. They're all integers. identical. The only difference is that it's like, what do you call it? Small, medium, large, extra large in Tim Hortons. It's exactly the same. I don't put the small cup separately, okay, because it only holds espresso in it. I'm not going to say that's an espresso cup. No, that's a small cup. It's suitable to put espresso in. You follow what I'm saying? That's what I'm saying. So don't give characters extra credit. They are just values. How to print them is the point. Okay? Now, because everywhere we're whining, oh my God, I don't know what true and false is in C language. What is true in C language?
I don't remember if it's 0 or 1, to be honest.
No, one more time.
Oh, like if either 0 or like 0 or 1 can be true or false. You can use either one.
Half true. Half correct.
Pass.
What is true and false in C language?
0 or without 0?
You got 0.5% for midterm added to your mark. Remind me of it. Okay? So that's what I do when people answer me good questions. We don't have true in C language. Anything that is not 0 is true. The only thing that is false is 0. Are we good with that? But everybody said, I don't want that. I want to have a true false. I don't want. So they did that. Okay? So they added that bool thingy to C language. So bool is essentially true or false. So you create a variable. You call this boolean. Okay, let me show you. So now, so in here I'm going to say, so we can have something like this. I can say bool condition, okay? And I'm going to set it to true. And I'm going to say C out condition. What's going to get printed? 1. Okay? So Boolean is just an integer that only accepts 0 and 1. So if I make that false, and now true actually means something. True means something. That means true. And I'm going to say condition. Now I'm going to say condition is false. Now I'm going to say C out condition. And the outcome will be 0. Are we good with this? Actually, thank you for reminding me. Where's my cell phone? I have to set that to quiet, to do not disturb too. Oh, it is on do not disturb. Interesting. When did that happen? Okay. All right. Now go back. No? There you go. All right. So, yeah. So that's that. Now let's see what happens if I do this. Condition is 453. You see what happened? Do I get an error? No, because it's an integer. Well, when you put integer in it, if it's not 0, it's going to make it 1. So you can use Boolean. It is more descriptive to return a Boolean in a function when you want the function to return a condition instead of an integer. We used to do integers, right? When something was true or false, we would say integer, and integer was 0 and 1. But over here, you return Boolean, so you know what's going on. We good? Are we good? Everything's OK? All right. All right, so we have, so essentially, character is 1 byte, short is 2 bytes, integer depends on the system, long is 4, long is 8, okay? Float is 4 bytes, double is 4, I think, and long double is 8 bytes. It's, so when we are talking about float double and long double, what is the difference between an integer and a real number? Okay, real numbers have partial parts, but the partial part is simulated. Remember that. Okay, which means when you actually put some value in there, it's never precise. It means you can create a double value and you put 3.5 in it, but what's actually inside is 3.4499999999999. And you have another one that is 4.5 that is actually 4.50. So logically, the values are the same. But in an if statement, when you put them in front of each other, because they are not exactly the same, the compiler is going to tell you they're not. The execution of program will fail. That's why you have to remember, this is IPC. I'm just reminding you of it. When you have floating point double or long double, stuff like that, you can never check them for equality. If you want equality to be checked, you have to check their absolute value. Don't be scared. There's no mathematics happening here. All you need to do is to reduce one by the other and make sure that the difference is lower than a certain value, the precision that you want. So if you want them to be equal, you have to make sure the difference between the two is greater than minus 0.0001 if you want to the thousandth, and it is less than 0.001. So the difference between the two should be within the tolerance. That's how you check for equality. That's one of the biggest sources of bugs in programs, when you are checking for something for equality and it doesn't happen. And that's a question that you're going to get in your quiz. So remember that. Why doubles cannot be checked for equality? You've got to be able to explain it to me. Let's put a fancy name for classes and structures. And now, let's put a fancy name for custom types. What are the custom types? If you recall, I said in C language, when you create a structure, you do not need to write struct again to create an object out of it. What was an object? What's an object? What is the difference between an object and a class?
Pass.
Was it that it one of them holds the class holds the definition of the object?
Yes. So one is the type. The other one is the instances of the type. Integer I. Remember when I said class and object, remember integer and I. Integer is the class. I is the object of type int. Okay? So remember I told you when you create a structure, the structure that you say struct employee E. When you say struct employee E, when you say struct employee and you explain what an employee is, later on when you want to create an object of type employee, you don't need to say struct employee anymore in C++. You simply say employee E. Why? Because any compound type becomes a type when you create them. Now, examples of compound types are structures or any other type that is created out of other types. The types that we have that they are not compound are primitive types. Character, int, long, short, integer pointer, character pointer, void pointer. These are primitive types, okay, that cannot be broken down into smaller pieces, okay, but by the language. Okay, everything can be broken down into bits. I understand that, okay? But what I'm saying is that you cannot, within your C program, you cannot break it down. So therefore, we call them compound types. The compound types are what we have for, So an array is a beautiful example of a compound type because you're saying integer A5. A represents 5 integers. So it's a compound type. We good? You understand what compound types? Okay. You know how to access them with a dot and all the good stuff. You see auto keyword? Forget it. You never heard of it. Got it? See no evil, hear no evil. We'll talk about it when the time comes, which is OOP345. We don't need it. Okay? Essentially, it means. So if you are lazy to write int over here, you can write auto x equal whatever you're initializing something. The compiler can see what you are initializing it to, and it uses the same type. So if you say auto x4, if I see you write it, I'm going to reject your thing. You're not using it. Okay? Because you don't know why. This auto is very useful when in 345 when we get to templates and lambda expressions and things like that. Okay? So here, now, okay, you don't need it at all. So write the damn integer. Why you're writing auto? Okay, or in here, what, right? Are you sure that it's double? It's not a float or a long double? You don't know, right? Don't do it. Just write what you want. Okay? So don't do auto now. None of your, I mean, too rich for your blood. Let's put it down. Declaration, definition. You write prototypes for functions, right? What is a prototype for a function? It essentially introduces the function to other functions, right? So they know that it exists, especially when you have modules, your workshop 1. Especially when you have modules, you have header files. In header files, you have prototypes of all the functions, and you have bodies of the function in the CPP file. So those bodies are definitions. The prototypes are the declarations of it. Now, you don't know, but you can actually declare a class too. When I say a class, a structure. Remember, structure, class, potatoes, same in C++, not in C. In C, we don't have class. Structure, class, potatoes, potatoes. So when you create a class, you can actually have a declaration for a class. You don't know why yet. You will use it halfway through semester, but at any moment of time, if you want to introduce that, hey, there is a transaction structure coming somewhere. Its definition is somewhere. Okay? Trust me, there is a class coming. Exactly as you say this. You're saying, trust me, there is an add function coming. The difference is that a declaration for a function explains everything you need to know about the function. So you can generate your code out of it. It tells you what arguments it receives. If you write your prototypes like this, I'll be very mad. Always put the names of the arguments over here, because then it explains what add is adding. Okay? Don't just write 2 ints. It's very bad. This is a bad thing to do. But anyways, so it explains it receives 2 integers and receives 1 integer, and the name is add. So you can literally complete the function calls without having the add, because you know everything about it, right? But the declaration of a structure or a class is incomplete. You don't know what's inside. All you know is that it's a class. That's it. You don't know what's inside. You don't know what is its size. You don't know what it carries. So this is a very loose type of declaration, which means you cannot use this declaration to instantiate a transaction. After having this, you cannot say transaction T. You can't do that, because the compiler doesn't know what's inside transaction to build one out of it. Okay? Unlike functions that they are fully complete with all the information you need with a function, and they call it forward declaration. Forward declaration of a class doesn't contain it. I'll explain when the time comes what it stands for and what you need it for. One definition rule. That's why we have the modules and safeguards. It means you can have I can write integer at int at the top of 5 different CPP files, and they all compile properly, as long as I have one definition of int adds in one of these that linker can find and link it to those things. One definition rule says if you are writing int add int, you're only allowed to have one body for the function in all your CPP files. You cannot have two of them. In one namespace, one definition. If there are two namespaces, fine. Then they are not one definition. They are two different definitions for two different namespaces. But if you are in one definition, each class or function is allowed to have only one body. Are you okay with this? We talked about all those. All right. Yeah. Read all these, please. Okay. You've got to come with questions. Scopes. Global scope, you don't know how to do it. The thing that they told you about global is a lie. It's not global. You said, they told you, if you write a variable at the top of your file, it becomes global, right? Remember that? Remember that? That's not. That's only visible to that file. Now that you're going to have 5 different files in one compilation file, and each one is compiled separately, the global thing that you call global is in the first file. The second and the third and the fourth file that does not have access to it. We'll learn halfway through the semester how to create actually a global object. Yes?
So like the certain and the CPP file, wouldn't we put it in the header file?
Then you are breaking one definition rule. Then you're going to have 4 different variables in 4 different scopes. First of all, there got to be 4 different variables. They are not connecting with each other. The first one has a different, the second one, if it doesn't collide. If it collides, then you got to break either you have 4 different variables, it's not global, or if it doesn't collide, or if you have one, then it's going to say why you have 4 different integers with the same name. Okay, we'll explain. You can actually write a declaration for a variable too. We'll teach it later. So you can actually create a file scope variable, and in the header file of that, you can create a declaration for that variable so other files know a variable exists and they can use it. We don't know how. So global is that. Visible to entire program, you don't know how to do it. We'll explain later. File scope is what you call global in C. It's not global, it's file scope. Function scope, it's the variables that you define in a function. Okay? And when the function ends, the variable gone. Are we okay with that? Okay? Class scope, you don't know yet. When we get to encapsulation. What's encapsulation? You can pass it, that's okay.
Pass.
Pass. The gentleman in front, I think, did you already say anything? Did you already speak? You didn't, right? So what is encapsulation? Do you remember? Putting the
Put in the data and logic.
behavior together, yes.
Yeah.
Because we don't know what encapsulation is yet, we don't know what a class scope is yet. We'll teach it soon. Visible to member function of the class. We don't know what the heck is a member function yet. So block scope, at any place that you open a curly bracket, you can create a variable in it. And that's not C++, that's C. So you can literally, out of nowhere, without any if, while anything, halfway through your program, you can open a curly bracket for no reason. As long as you have a matching closed curly bracket, you can define a variable in there. And when that block is finished, the variable vanishes. Now, this could be a block of an if statement too, a block of while too. It doesn't matter. Okay? So block is essentially anywhere you have an open curly bracket, you can create a variable and the variable. Going out of scope, I'll just explain. When the scope is over, they all die. You okay with that? Now, if you have an inner scope, which means you have a block inside another block, and you have 2 variables with the same name, inside and outside, there is no collision. The only thing that happens is that the inner one shadows the outer one. So if I have something like this, and this, If I run this program, 3 years later, I'm going to have 20 and 10, which means when I'm inside, it means when I'm inside here, this eye, we shadow that one. Anything you do to this eye happens to the eye inside that inner block. And that block can be anything. An if statement, a while statement, a for loop, a structure, a function, anything. Okay? Remember that. When you have an inner scope, when you identify this scope is within another scope, and you have the same variable name, whatever you do in this variable will shadow the other one. Okay? It's actually very simple and straightforward. Okay? If somebody's outside of this classroom, his name is Joe, and I have somebody in here, his name is Joe. When I say, Joe, who's going to call answer first? It's the same thing. But if there's nobody in here, I say, Joe, nobody answers. Then I shout, oh! The person outside will actually live here, right? It's the same thing. Okay? So remember that. When you have an inner one, it shadows the other one. Are we okay with this? And please generalize when I teach you. Don't ask me, what happens if it's an if statement? What happens if it's a while? Any type of inner loop, inner scope. Inside an outer scope, if you have the same variable, it shadows. Good? Shadowing. Okay. Oh, here comes the schmiggly dingy. Okay. So this one is shadowing. Okay, so I want to draw a bar. Oh, let me take that foo-fa thingy out of here. By the way, you don't need to have those things inside header files for a header file to exist. Remember, include is a dumb copy and paste. We just put it in header files to organize our code. As long as it's present and its path is accessible, it includes it. It doesn't matter. Okay? So, add new item. I'm going to add bar.h. All right. Who has the microphone? What do I write? I said, with your eyes closed, you need to be writing an empty thing. I have bar.h. What this actually is your question in the quiz that is coming up. I'm going to tell you, I have a header file called car.h written in BMW company. I want you to tell me what the header file should look like. You have to tell me it looks like it's going to be, if not defined, BMW underline car underline h, define BMW underline car underline h, namespace BMW open close, and endif. That's it. Okay? Now when I'm saying car.h over here, bar.h over here, we know that we are in Seneca, so the namespace is Seneca. Hence,
hashtag if undefined.
If not defined.
If not defined, Seneca.
All capital Seneca.
Underscore bar. Underscore dot h.
H, perfect. When you do this, don't try to retype it, because you will make a boo-boo in writing Seneca bar yada yada, and your safeguard is not going to work. Always copy and paste. Always do this. That's my experience. And highlight this and write define. Believe me, that's going to save you lots of time. Always do this. And then what do I write?
Namespace Seneca.
Thank you. All lowercase, and now I'm ready to write. Thank you. All right. Questions? Suggestions? Objections? Yes.
So in the quiz, will it just be like a random one, but it'll be still inside Seneca, right?
No. When I tell you which company to write in, okay, or which department, I'm going to say, I'm going to say in finance department we are implementing a student class, and the student class needs a header file. Tell me what is the name of the header file, and the thing. Then you can come up, you can call it STD&T if you want to. But as long as you go through all the specs properly like this, you're good to go. Okay? In the addendum, we are saying 10 quizzes. That's an approximation. It could be 6, it could be 12, it could be 13. I don't know. Okay? So just remember that. It's the more quizzes, the better. Don't be mad because she's. But okay, all right. So now I want to write a function. So my function wants to draw a bar. So I'm going to write here void bar. So I'm going to write a bar like that, a linear bar like that. If I want to write a bar like that, I want to. So what do? First, I have to use a character to draw it, right? So I'm going to write over a character, fill it with something, right? And then I need to know how long it is, okay? Now, a new type in C, it's not a type. It's a type def. But essentially, it means unsigned integer. It's called size t, okay? Size t essentially means an unsigned integer. It's within the language. I use it so you know. Actually, int. Let's not clutter it. OK, so int. In here, I'm going to call it length. So that's my bar, right? And then I'm going to create bar.cpp over here as my so if I told you, another catch is coming. If I told you, create a module for a car, did I call it car? No, it's bar. OK, if I told you to create a module for a car, then you have to give me two things. You have to give me the header file, and then you have to give me a C++ file that does include, does include bar.h and namespace Seneca. That's an empty module, okay? So with an empty module for bar.h, this is added to it. So if I ask you to create a module for an employee in Google, then what's going to happen for you is going to be Google underline employee underline h, you do all those good stuff, and then the employee.cpp is going to include employee.h and yada yada. Are we okay with this? Now I want to write one of the good features with IDEs is that you can do lazy stuff. I can actually come over here. You see that screwdriver? I can do like this, and I can say, create definition of bar in yada yada. Poof, and it creates a definition for me. So it's very useful. You don't make a typo or anything like that, okay? So it's created. We're good down to this point. All right, so now let's create a bar. So what do I do? In here, I'm going to say, now, I want to print the bar, right? So do not include the IO stream here, because nothing is printed in the header file. Again, all these things that I'm giving you are advices and things that you need to know. Includes are only included where they are used. Don't never, ever in your life have just in case includes. That's going to bloat your source code. Just imagine if you include 5 header files just in case, you are adding 5 humongously big C files, C++ files, to your source code. That's very bad. Only include where is needed and when it's needed. Okay? Here, I don't need any include. Here, I do. So up here, and system includes are always at the top. So I'm going to say include IO stream. And because I'm going to use IO stream a lot, I'm going to say using namespace std. Okay? So now I'm going to do the bar thingy. So I'm going to say for integer I set to 0, I less than len, and I plus plus. Actually, I can say cout fill. I cout fill, comma, and I plus plus. Right? And in here, I'm going to say cout and L to go to new line. So that's my bar. I can actually come to bar.cpp, to my prg.cpp. In here, do I need IO stream? Nah, I don't. I don't want to print anything. I just want to use the bar. So in here, I'm going to say include bar. dot h, this help thingy sometimes. And now I'm going to say using namespace. What?
Seneca.
Seneca, thank you. Now in here I can say bar with a dash and 40 characters. 40 characters long. When I run this beautiful program of mine, 3 layers later, I'll have that one. Are we okay with this? Questions down to this point? Suggestions? Objections? All right. Anybody's extremely tired and want to go for a break? Or you want to go 5 minutes earlier, 10 minutes early? Break? 5 minutes. 12:05, I'll continue. Pause and remind me to please resume. So now that we have created this bar thingy, sometimes I want to create a bar that actually, let's change the bar. I'm just going to change the bar. Yeah, let's change the bar. I'm going to put the fill last. So character fill. I'll tell you later on why, because that just makes more sense. You'll see it. So I'm going to say 40 in length with dash. OK? Now, let's say, so it's exactly the same. I just switched the arguments. We good? OK. Now, let's say I want to draw a bar with dashes only. If I want to do that, then I have to create another one. Bar with dashes. And just pass the length to it, right? Obviously, I can reuse my code over here by simply call the other bar and pass the length and a dash to it, right? Are we OK with this? So now in main in here, I can say this one is going to be with that one. And I'm going to say over here bar with dashes. And I'm going to put over here 70. Are we good? OK. One of the very first things with polymorphism that we learn in C++ is that unlike C, the signature of a function is not only its name, but it is its name and its arguments. What is a signature of a function? What is a signature? What is the meaning of a signature? Signature is what identifies someone, right? You do scribbly thingy and that's me, right? And nobody else can do it because you have a specific handwriting type of thing, right? Are we OK with that? So signature is that. So in C language, signature of a function is its name only, which means you cannot have two functions with the same name and different arguments, right? In C++, that's not the case. I do not need to call this bar with dashes. Actually, what I'm going to do over here is this. Dashes. OK? I should have this open at. Actually, there is another thing that you can have always open. You can go to your repository, right-click on your repository name, and open git sync. That has everything handy. You can just set it aside and just push and pull and commit very quickly. OK, I'm going to put it over here at the side so I don't have to open this again and again and again. So going back over here, now what I can do is just call this bar. OK? That's polymorphism, which means you have the same function doing the same thing in different ways. That's the first feature of polymorphism that you see. We have many different levels. C had polymorphism. you didn't know. How? You write integer I, integer A, then you write double B and C, and then you write C is equal to B plus A. That plus receives a double and an integer. And then the next time you do a plus with two integers. So plus works with everything, right? That's kind of polymorphic too. Same action, doing the same thing in different ways, right? But you will see later on, we call these things, I call them fake polymorphism, because it's not really polymorphism. When you look at it closely, like for example for this one, when you look at it closely, all C++ is doing is adding the types to the end of the bar. So the first one is bar int char. The second one is bar int. So when you are calling it, the first one is bar int char. Therefore, the names are different, but it's behind the scene. You don't see it. It's fake, but it's polymorphism. Nevertheless, when you are doing it here, the names are the same, right? So this is overloading. This is called function overloading, and it is the first polymorphism that you actually see right out of hand. So for example, if let's say if I want to print a, like I can say I can have a bar with no arguments whatsoever, and that means 70 characters or 79 characters. Okay? So I'm going to make this one 20, and this one I'm going to make it 40, and I'm going to say if I call bar, by the way, if I compile this, will it work? If I compile bar.cpp, will it be okay? I didn't create this bar yet. Let me save everything. That bar doesn't have definition. If I compile prg.cpp, will it fail or will it work? It will not fail, because compilation happens in different stages. Each file gets compiled without knowing other files exist. This file is including bar.h, and bar.h has the prototype for bar. So it trusts it. You compile it, it compiles it successfully. It cannot link it because the definition of bar doesn't exist. Remember your compiler design, the compiler that I wrote, how compiler works. Each file is compiled separately. If I compile this just by itself, if I go over here and say compile, just compile, it's successful. But if I actually build the whole thing, then it's going to tell me unresolved external symbol yada yada bar. And as you see, what does it start? LNK, linker. It means the linker is giving you error. Compilations were okay, but when I was actually trying to putting together, the definition of a function is missing. Okay? So keep that in mind. And thank you for falling in my trap. All right? So now I'm going to go over here and actually create this. And I'm going to write over here, I can say bar with, say, 79 characters and underline, something like that. So if you don't mention how you want the bar, this is how it's going to run. And they all work. Are we OK with this? Everything's OK? This is called overloading, function overloading, when the names are the same. But not always you can call the other one. Sometimes what you do inside is very different. OK? So just remember that the contents of the function are different. I made it like this to be easy. OK? For example, I can create another one. And you can actually do this. I can say void bar or character fill. And create this one. And in here I can say bar. Actually, let's first not do that. Yes. What happens if I do this? I didn't create it. You have enough information. Who has the microphone? You have the microphone. What's going to happen here? Put your inquisitive mind at work. You want to pass or you want to?
Pass.
The gentleman over there now.
It's gonna give integer value.
What is the integer value for A? Anybody remembers? 65. So it's as if you called bar with 65. It's going to print 65 dashes, right? Because a character is nothing but an integer. I just told you. So connect the dots, right? When I ask you a question, usually I'm reusing what I taught in a class. So you see that? That's going to be a walkthrough for you. I'm going to do that to see if you actually know what happens. I'm going to write these exactly like that. This is how my question of the quizzes come out. I'm going to do it like that. I'm going to tell you what the walkthrough is. You need to understand that that's an ASCII code. Okay? Usually in these kind of scenarios, I'm going to say the ASCII code of, I'm going to put over here C, and I'm going to say the ASCII code of A is 65. So you need to know B, C, it means 65 plus 2. Okay? You need to know that. All right? All right, so I'm giving you out the question, so you know that. So now in here, I'm going to say void bar character fill, and let's see if this works. Come on, you can do it. So in this one, I'm going to call bar, say with 79, and fill. Now if I run the program, there we go. You see just what happened? Now it picked the right one. A few years ago, that wasn't possible because we are coming to type safety. You'll see they're making the types in C++ more strict. Long time ago, in a galaxy far, far away, when we did this, when you passed actually a character, the compiler will upcast it to an integer, pass it, and downcast it to a character. Because of that, this type of overloading wasn't possible. The compiler would tell you, hey, this is an integer too. You cannot have two different things, because still one definition rules applies, right? So, but now you can do this actually. It identifies between the two. Character is a different type than an integer. Are we good? All right. All right. So this one is overloading. Commit and push. Okay? So now that we have overloading, let's actually see what else can be done. So I'm going to bring the bar, instead of including bar.h over here, I'm going to get bar.cpp in here, get this bar of mine, copy, and bring it right over here. Okay, so I'm just having a bar, okay, like that. Are we okay with this? Now, these two are not defined, right? I don't have the header file, and I only have one definition of bar. Another feature of C++ is that you can add default value for the arguments of a function inside its prototype. So I'm going to do it like this so you see what I mean. I don't want to create another header file. You get the message. You know what it is. So that's what it is, right? I can actually say, hey, compiler, and you can only do it from right side. You can fill it from right side and go to left, okay? So I'm going to say, hey, if fill was not provided, put this one instead. So in here, I can say, As you see, the second one is now having some meaning. That means I have 5 minutes. Okay? You follow? So now by adding that default thing, compiler says, oh, you provided both, I'll ignore the default value for the argument. And I'm going to use both. This one you provided only one? Sure, no problem. Now I'm going to put 40 for length and pick up the default value. Even if you want, you can put for the first one. But you cannot do it the other way. Remember that. So many people do that. So I'm going to put 79 over here. Now everything works. Now if I actually run this, you'll see that it actually runs it, and it works like that. Okay? Of course, I cannot give a different meaning to it. But if that's all I want to do, I cannot give a different meaning. I cannot say if bar with 40 is printed, use this and that. You know what I mean? You cannot give it. It has to be exactly the same way. It has to be the same function. Okay? And I cannot have this in here. If I say over here bar A, you know what's going to happen. It's going to print the A. It's going to print the 65 of them. There is no way that if you want character to be first, you have to overload it. Default arguments won't work. Also, you cannot remove the dash from the second one and say, if the first one is missed, but you cannot. It's from the right side. You cannot change the syntax of the language. The syntax of the language requires the arguments to come in that direction. Therefore, default arguments can only be filled from right side, not left. Are we okay with this? Are we okay? Okay, one. Are we okay, two? Yes, we're good? Goody, goody. So, so this one will be for function arguments. So you can do polymorphism even without implementing anything. Right? You can actually make a function work in 3 different ways without even. So this one is going to say sets len to 79. 79. Oh, 65. What are you talking about? 65. And in here I'm saying ASCII. How do you write ASCII? Double CI or I like the ASCII code? ASCII code of A. Okay? Save it, and I'm going to commit that. I'm going to say common mistake. Are we okay? All right. Oy, 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 oy. So, who's going to be volunteer to tell me where do we continue for the next one? Somebody? That's going to be the lab that you're coming in. It's going to be lecture. The lab that you're coming in, you're going to have 15 minutes to submit your workshop because your workshop is C, it's not C++. You're supposed to just organize things, okay? So you have 15 minutes to submit. Make it ready, put it on thing. Use dash feedback to make sure it works. So you write the submission command and you write dash feedback at the end. It dry runs your submission without actually submitting it. Then you come to the lab and you submit it from the lab, okay? From the lab computer. You have around 15 minutes to do it, and the rest will be lecture. And who can tell me that continue with references? You will do it? Continue with references. So next time we're coming, continuing with references. Please study down to this point. Come with questions. Any questions? Any questions? Suggestions? Objections? All right. Have a good day.